Hi, as we discussed in the last class that any point in the 3D space can be represented by r cap, theta cap and a phi cap into the spherical coordinates. Now let's try to visualize the direction of r cap, phi cap and the theta cap. Okay, so as you can see from this picture, try to visualize the directions. Okay, r cap is always the radially outward. So if you go into the direction of radius, then you will find the direction of r. Okay, so and remember, when we are going into the one particular direction, other two coordinates would be the constant. Like if you are going into the direction of r, then the theta and the phi would be the constant. So just check it. If you are going into this direction, then this theta would be constant because this is the angle from the z-axis. We are not when we are going into the direction of r, and this phi is angle from the x-axis. So this would also be constant when we are going into the direction of r. Yes. Now let's look at the direction of phi cap. Now when you will move into the direction of phi cap, the r radius and the theta, which is the angle, vertical angle from the z-axis, would be the constant. Okay, so just imagine we are at this point. Okay, so this is our angle theta and this is our radius r. Now if you will keep the r and theta constant, and if you will try to move from this point, then you can see you will be going into this circle. Yes, you will be tracing this circle. You will be going like this, and the direction of phi would be always tangent to this circle. So if you are at this point, then the direction of phi would be this. Okay, fine. Now let's look at, so one thing, the phi cap is parallel to the xy plane. As you can see, there is no z component in the direction of phi cap because it is parallel to the xy plane. So you are going, when you are going into the direction of phi cap, you are moving into the xy plane kind of. Okay, you are not going into the direction of z. Fine. Let's look at the direction of theta cap. So now the r and phi would be the constant because you are moving into the theta cap direction. So r would be constant. So let's keep the r this and keep the phi at this angle. Okay, so we are kind of at this point. Okay, keep the phi constant. Now if you keep the phi constant and will try to move around this sphere, then you will be tracing, just visualize, you will be tracing this vertical circle. Okay, because in this vertical circle, the phi is constant. Yes, in this vertical circle, if you are at this point, then also the phi would be constant. Okay, so okay, fine. So you will be tracing this vertical circle. Now let's try to get this relationship. So we want to have the r cap, theta cap and phi cap in terms of the Cartesian unit vectors x cap, y cap and z cap. One thing I wanted to tell you, that these r cap, theta cap and phi cap makes the orthogonal basis set. What is the basis set? So in the Cartesian coordinate, I said x cap, y cap and z cap are the orthogonal basis set. That means any vector A can be represented in the form of x cap, y cap and z cap, any vector. Okay, now similarly this r cap, theta cap and phi cap makes the orthogonal basis set. That means any vector A can be written into the form of r cap, theta cap and the phi cap. Okay, any vector in the 3D space can be written into the form of r cap, theta cap and phi cap. Okay, that is fine. Now let's try to get this relationship. So if this is the direction of r cap, yes, then what would be the x component, the y component, and the z component for this unit vector r cap. Okay. So I can put this r vector. Let's say this is our r vector. Okay, you can put the vectors at any place. Vectors do not have any position. Okay, vectors only have the magnitude and the direction. Okay, so this vector I can put at the origin. Okay, let's say this is our r vector, because the direction is same, direction is in the radius, and the magnitude is also same. Okay, now we want to find the x component. So let's try to find what this would be. So this is our angle, which is 90 minus theta. Okay, because this is our angle theta. So this component, this yellow component would be r cap sine theta. Yes, because this angle is 90 minus theta. Yes, and now just try to take the x component and y component. What would be the x component? So this is our angle phi. So this component, this x component, would be simply r cap sine theta cos phi. Yes, and the y component, this y component would be r cap sine theta sine phi. Yes, so let me remove and make it clear. So this component is r cap sine theta cos phi. This angle is 90 minus phi. So this was r cap sine theta, and this is our 90 minus phi angle. So this would be the y component, and that would be r cap sine theta sine phi. Okay, this is r cap sine theta, and if you take the component of y, then r cap sine theta sine phi. So you can see the magnitude of this y component, r cap magnitude is 1, so the y component would be simply sine theta sine phi, and the x component is sine theta cos phi. Okay, the magnitude we are only considering. Now let's try to get the relation between theta cap and x cap, y cap, and z cap. So this is the direction of theta cap. Yes, and if you take this vector, this would be making the angle theta. Yes, so this would be 90 minus theta. Yes, this would be 90 minus theta. So this yellow component, if this is the theta cap, so this yellow component would be theta cap sine theta. Yes, this yellow component. And if you make the other component, it would be theta cap cos theta. Yes, and now you can see this component, this green component, is parallel to the xy plane. Okay, so I can put this green component as like this. Yes, so as I said, vectors do not have a position. You can put any vector to other place as long as the magnitude and the direction are the same. So we can write this is our vector theta cap cos theta. Now you can easily find the x component and y component. So this is our angle phi. Yes, so this x component would be theta cap cos theta cos phi, and this y component would be theta cap cos theta sin phi. Okay, So the magnitude of the bicomponent would be cos theta sin phi. Yes, cos theta sin phi, as you can see in this relation. And the x component is cos theta cos phi. Okay, this is the x component. And what about the z component? So let me remove this. So this is the theta cap, as we said. So this would be our z component. Yes, and this was our parallel to the xy plane. So this was the angle 90 minus theta. Yes, this angle is 90 minus theta. So what this z component would be, this yellow component would be theta cap sin theta. Yes, and it is in the direction of negative z. Yes, so the z component would be minus sin theta, as you can see here. Okay, just try to visualize these things. Okay, I may not be efficient in showing you all these things, but I am just deriving these results. Okay, now similarly let's do it for the phi cap. So this phi cap, as we can see, is the parallel to the xy plane, so it does not have any z component. As you can see, it does not have any z component, only the x component and y component are there. Now what would be the x component? Let's first find. So just draw this vector into the xy plane. Okay, as I said, vectors do not have any position, so you can draw these vectors as long as the magnitude and direction are the same. So this is our phi cap, and which is perpendicular to this line. Okay, now let's look at this vector. This will be making the angle phi. Yes, so the bi component, this yellow component, would be, so okay, this is perpendicular to this line, so this would be, this angle would be, this green angle would be 90 minus phi. Yes, so this y component would be phi cap, the x component, phi cap sin phi. Yes, and it is in the direction of negative x. Okay, this is in the direction of negative x because x is in this direction. So the x component is simply minus sin phi. Yes, and you can look at the y component. So this y component would be, so this was the phi, so this component would be phi cap cos phi. Yes, it is in this direction, so it is in the positive y direction. So the y component is cos phi. Okay, so what I am saying, you might be again deriving these relationship with the help with your visualization. Okay, I might not be very clear because it takes a 3D visualization approach. Okay, you cannot I cannot make you very efficient in the visualization. Okay, you have to imagine these figures in your mind. Okay, so but I want to tell you, this is the relation you should get when you are deriving this equation. And I want to tell you that in the Cartesian coordinate system, x cap, y cap and z cap was the constant. Yes, so whenever you are moving into the 3D space, the x cap, y cap, z cap would be the constant. So you can always take out these x cap, y cap, z cap out of the integral whenever you are taking some integral. But as you can see, r cap, theta cap and phi cap are not the constant. As you can also see from the figure, if you are moving from this point, let's say you are at this point, let's say this is point B, this is point A. So if you are at point B, the direction of r cap, phi cap and theta cap would be different. Yes, so r cap would be in this direction and previously it was in this direction. So r cap, theta cap and phi cap depends on the theta and phi. Yes, so you cannot take these r cap, theta cap and phi cap out of the integral. Okay, so just remember, let me write it, r cap, theta cap and phi cap are not constant. Okay, not constant. So if you will try to see del r cap by del theta, then you will see you will get this theta cap. Okay, so r cap is not constant, otherwise it would be differentiation would be 0, but here you are getting dependency on the theta cap. Okay, so just remember these points.